talking about stoichiometry, basically condensed. If you have any more questions, I have a ton of videos on stoichiometry and multiple conversions. Alright, basic wow, that's a great start. Stoichiometry, Avogadro's number, 6.022 times 10 to the 23rd. You can use this for particles or whatever you want. Like in here. Okay, molar mass. Molar mass of 1 mole of a substance. Each element's molar mass can be found on the periodic table. For example, silver has a molar mass of 107.87 grams per mole. So let's just look at carbon, for example. 12.011, so that means that 1 mole of carbon 12, will weigh 12.011 grams. Pretty interesting. Okay. Now you can use this for molecules such as CO2. So you have 2 oxygen atoms, so you multiply 16 by 2 because 16 is the mass number of oxygen, plus 12, 1C, and you get 44 grams per mole. Mole map. Pretty simple. If you're going from moles and you're going away, you're multiplying. And if you're going from something to moles, you're dividing. Yep. Pretty simple. With this, you're using the atomic mass units, as just previously mentioned. If you're going to particles, that is Avogadro's number. And if you're going to liters, it's 22.9. But that is only at standard pressure, but I really wouldn't have to worry about that at all. Okay, percent composition. To calculate the total molecular mass of each compound, yep, so up here. Then calculate the mass of each element in the compound, then divide the element's mass contribution by the total molar mass and multiply by 100. Okay? Empirical and molecular formula steps. Convert percent to grams. This can be done by assuming that there's 100 gram of a sample, even if there's not. Convert grams to moles. Determine the ratio of moles by dividing the smallest mole amount, and do that to every other. Write the empirical formula using the ratios as the subscripts, as mentioned in the previous videos, if you're paying attention. Okay, now actual stoichiometry, the fun part, in my opinion. I really like these. A little bit too much. Anyway. So we have an equation, a combustion reaction, if you haven't noticed, where you combine a CH plus oxygen and you get CO2 plus water. This is all balanced. And there's 2 questions. How many moles of water will be produced from 20 moles of O2? Now that means that, what if you have 20 moles of this? 20 moles. Okay, but we want to find out how much water we produce. So, we have 20 moles of O2 divided by 1, multiplied by 4 over 5. Now you might think, why 4 over 5? Well, it is because you're going from O2 to water. So you do 4 to 5, because that your multiplication factor. Now, if it's a 1-to-1, then it's a 1-to-1. You can kind of ignore it then. And since we're going to moles, we don't need to convert back to grams, and we get 16 moles of H2O. Okay, number 2. A little bit more complicated, still super simple. How many grams of water will be produced from 125 grams of C3H8? So we need to go from grams to moles, then do a mole conversion, and then go back to grams. Okay, so 125, just over 1, then multiply it by the molar, and then you want to do 1 divided by 44.11, basically so you can put it into moles. So after this point, so this is just converting this to moles, and then the molecular ratio from up here, and then just to convert H2O, moles of H2O back into grams, and you get 204. That's it for basic stoichiometry. If you have any more questions, just look on my channel, and there's plenty of videos on YouTube. Thank you for watching. Bye-bye. Have a nice day.